Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Hope we are all fine and healthy during this pandemic COVID-19. Okay, I would like to present part of my research. This is preliminary research. I said part of the research that actually we want to make a model how to evaluate land suitability based on satellite image data. This research conducted by me and HERWIN LUKITO from Environmental Engineering Program Study. As the background, actually, that land suitability assessment actually is a long time ago. We have already settled method to do that. And the FAO framework is the most popular framework to do this land suitability evaluation. And it was most widely applied in land evaluation, but it required the availability of detailed land characteristic data. So it needs very big effort to collect the data from the field, as well as also from the laboratory analysis. And besides, it is also found that the evaluation of land suitability or land quality or soil health, more or less, it tend to use the parameter that not very fixed or fixed value. I mean that sometimes we find that our land, our cultivated land may change dynamically based on the cultivation practices we do. So sometimes we detect that maybe the land suitability will be changed also. And based on the FAO framework and the land characteristic that's stated by the procedure, sometimes we cannot find that is it possible to change the commodities. So this is very challenging to try to suitability, and maybe also can dynamically change based on the effect of the cultivation practices. So based on that two reasons, the developing of a remote sensing data to use as a data that we evaluate land suitability may be very beneficial. So when we know that recently remote sensing technology and GIS is developed very quickly, and it supports greater ease and accuracy to get the remote sensing data, and also GIS provide a more productive analysis and easier data access. So the need that we want to develop land suitability methods is using remote sensing and GIS is much more interesting. We use Sentinel-2 data for our research because Sentinel-2 data, it is a multispectral program with a detailed spatial resolution and also frequent temporal resolution. We can download it every the satellite capture every 10 days, and the resolution, spatial resolution, is 10 meters, and it can be downloaded freely from the ESA website, European Space Agency. So we can get it freely and very high resolution for temporal and spatial. It was used widely for many environmental analysis, including like surface or even also ocean analysis for the bathymetry or something else. One main objective of this research is to determine the suitable land for rice production region based on remote sensing data. So we try to develop how to, we want to try to make a map, how to develop land suitability map based on the data. So we retrieve, I retrieve the satellite image from Sentinel-2 from various capture time, because we have to select the most cloud-free image. And we do geoprocessing for the image cropping. Then the main parameter is NDVI. So we select the most cloud-free image and we calculate the NDVI from that selected image. After that, based on the NDVI, we go to the field for a ground check. And to develop the land suitability map, we process the NDVI data, converted to raster, and then raster is classified. Each cell is reclassified to the suitability level. And finally, the output is presented as a land suitability map. Several images that we already captured, we can see here from the recent one on May 2021 and on April 2021, we still see here so many clouds. The left one is TCL true color, and the right one for each date is NDVI map. And the previous year, we try to download from 2019. We can see that they're much more cloud-free. And 2020, similar with 2021, we found some cloud, so it will be disturb the analysis. So based on that image that we have captured, we select that maybe the screen capture, the image capture from 2019 will be selected with the database to analyze the NDVI and land suitability. So I just want to make a comparison. The left one is a land suitability map resulted from my previous research. And we classify that it's in the northern part of Sleman. We can find here the classes of land suitability. The blue, light blue is not suitable, and the purple is marginally suitable, and the pink was suitable. As compared to the NDVI-based analysis, we can find here that the area that is very low or very high NDVI, it's shown that it is not suitable. So we can see here around the city in this part, in this very light green, it is as compared to the previous map based on the soil data, more or less it is corroborate one and more. And in the summit of the Merapi, we can see here that it is very, very dark green or even more light blue. It is very high because this is the different color. So we put it not suitable. And we say that there's a preliminary land suitability for rice based on NDVI. And just for showing the field check, we do some field check to visit the location with the different NDVI. And you can see here, this is still a vegetative phase of the rice. This is almost harvesting. And what is still in progress, I said that we have still have to validate the temporary map that I showed previously, and still in progress, because more or less we have constraint to do field checks and measure directly in the field. So this is still in progress, and we have to check which one have the best correlation with the actual yield. So the background theory is land which is suitable for rice, it will produce high rice. Or we can say that we try to develop land suitability map based on rice productivity. As this morning, Professor Iin said that there are two groups. The one is soil productivity, another one is based on soil data. And this research try to develop land suitability based on the soil productivity. So whenever the soil is a high productivity for rice, we can conclude that it might suitable for rice. So based on that theory or that assumption, so we can make a different approach, that land suitability can be mapped dynamically based on soil productivity. So we can use the satellite data to deal with this importance. So just for the summary or conclusion, we can already use Sentinel to map the irrigated rice field, and it is still fine that some image capture still have a cloud cover, that we have to select which one is better for the next analysis. I think that's all. Thank you for your attention. I will very happy if you have a question or comment on my presentation. I will try to do my best to answer. Thank you, Prof. Nurkolis.